review of a short history of nearly everything by Bryson. From the author's introduction, one can deduce that when he was growing up, he was convinced that science was supremely dull. This was due to his disappointment with the science books he studied, which failed to answer fundamental questions such as, how did we end up with a sun in the middle of our planet? And if it is burning away down there, why isn't the ground under our feet hot to the touch? This disappointment may be why he became an author journalist rather than a scientist. However, about 4 or 5 years before he was writing the present book, probably in his mid-40s, on a long flight across the Pacific, he became keenly aware of his lack of knowledge about science in general and our planet in particular. He felt this to be unacceptable and decided to remedy the situation by devoting a portion of his life, 3 years it turned out, reading books and journals and finding experts who were willing to answer a lot of his outstandingly dumb questions about various fields of science. He succeeded in understanding and appreciating the wonder and accomplishments of science at a level that isn't too technical or demanding, but also isn't entirely superficial. He was able to convey this understanding and appreciation to the general reader in this book entitled A Short History of Nearly Everything, a Remarkable Achievement. The book begins with the Big Bang and astronomy. It then proceeds to physics, chemistry, biology, geology, oceanography, and anthropology. Among the topics discussed are how scientists arrive at the age of the Earth, what is in Earth's interior and its ocean depth, theory of continental drift, theory of the cyclical changes of the Earth's orbit causing the onset of ice ages, origin of life, bacteria, cells and DNA, apes and humans, Darwin's evolution theory, and Mendel's gene theory. The description of how life began on our planet and how humans evolved and scattered on different continents are particularly detailed and thorough, though not easy to follow. Both the good and the bad of human nature are laid bare in the account that at the same time Newton and his fellow scientists were ushering the beginning of the scientific age, a group of humans were brutally wiping out the existence of the gentle, flightless bird Dodo, a creature that never did us any harm. The author concluded that if you were designing an organism to look after life in our lonely cosmos, to monitor where it is going and keep a record of where it has been, you couldn't choose human beings for the job. Of the many new knowledge I learned in the book, the one about the atom stands out. According to the author, atoms never die. They are recyclable, migrating from a dead person to a plant or another living person. He states that a significant number of our atoms, up to 1 billion, probably once belonged to Shakespeare, another billion from Buddha, and another billion from Beethoven. How nice! He also points out that the personage have to be historical, and it takes the atom some decades to become thoroughly redistributed. Thus, however much you may wish it, you are not yet one with Elvis Presley. There are interesting stories about a number of scientists. Some are well known and some are not. James Hutton, father of geology, had the reputation that nearly every line he penned was an invitation to slumber. Dr. James Parkinson, of Parkinson's disease fame, was a geologist and a founding member of the British Geological Society. The originator of the famous tongue twister, "She sells seashells on the seashore," was a young lady named Mary Anning, who found a fossilized sea monster 17 feet long in 1912 on the Dorset coast. She was then about 12 years old. Anning would spend the next 35 years gathering fossils. The chemist Humphrey Davy was addicted to laughing gas, nitric oxide, and probably died from it since he drew on it 3 or 4 times a day. When the astronomer Edwin Hubble died, his wife never gave him a funeral. It is not known where he was buried. So, if you want to pay him your respect, you must do it by looking at the sky and try to locate the Hubble telescope. Max Planck worked on entropy without knowing that the subject had been beaten to death by William Gibbs. When he found this out, he simply switched to the black body radiation problem. In solving this problem, he came up with the idea of the quanta, opening up the new field of quantum physics. Fred Hoyle and William Fowler jointly developed the theory of nuclear synthesis, but the Nobel Prize recognizing this work somehow did not include Fred Hoyle. Despite the wonderful discoveries of astronomers, the author offers the following sobering sentence about the state of the field. Quote, "We live in a universe whose age we can't quite compute, surrounded by stars whose distances we don't altogether know, filled with matter we can't identify, operating in conformance with physical laws whose properties we don't truly understand." Quote, concerning physics, the author is to be complimented for not shying away from attempting to explain the exotic standard model and the many-dimension string theory. Despite his efforts, most readers would agree with Paul Davies that matters in physics have reached such a pitch that it is, quote, almost impossible for the non-scientist to discriminate between the legitimately weird and the outright crackpot, end of quote. In conclusion, in addition to filling gaps in my knowledge about science and scientists, reading the book has brought many smiles to my face due to the author's writing style. I highly recommend it, irrespective of your level of scientific knowledge. I am confident that you will find the book both readable, educational, as well as entertaining. End of review.